Hey everyone. Ready to dive into some seriously mind-bending stuff?
Oh, yeah.
Today we're tackling quantum computing.
All right.
This topic is it's generating tons of buzz,
Right.
but also a fair bit of confusion, I think.
Yeah, a lot of people have heard of it,
Yeah, everyone's heard of it.
but not a lot of people really understand what it is.
Exactly. So we're here to try to clear things up.
Yeah, try to extract the most interesting insights and leave you with some aha moments.
Yes.
Hopefully, give you something to think about.
Exactly. And to help us do that, we've got a great lineup of sources today.
Awesome.
We'll be pulling from a few different YouTube videos. So, Quantum Computers Explained by Science ABC,
Okay.
and then a piece featuring the tech experts MKBHD and Cleo Abram,
Oh, very cool.
and then The Map of Quantum Computing by Domain of Science.
Yeah.
So we're covering a good range of different perspectives.
A nice diverse set of sources.
Yeah. Okay, so
Always good.
let's start with the basics. What's the fundamental difference between the computers we use every day
Yeah.
and these quantum newcomers?
So the computers we're familiar with rely on bits,
Okay.
which can be either a 0 or a 1.
Okay.
It's a very simple system. It's either on or off, like a light switch.
Got it.
Quantum computers, on the other hand, use qubits.
Okay.
And qubits leverage the strangeness of quantum mechanics to do something very incredible.
Okay.
They can be both 0 and 1 at the same time.
Whoa.
It's called superposition.
Okay. So it's not just that qubits are faster.
Right.
It's that they operate in a totally different way.
Totally different way, yeah.
The Science ABC video used a good analogy
Right.
of a spinning coin.
Right.
Is it heads or tails? Well, until it lands, it's kind of both.
Yeah, it's in a superposition of both heads and tails.
I like that. Okay.
And this ability to be in multiple states at the same time allows them to hold and process a lot more information than a traditional bit.
That makes sense. Okay.
Yeah.
But wait, there's more, right?
There is more.
What about this thing called entanglement?
Entanglement, one of my favorites.
Okay.
So entanglement is another key principle of quantum mechanics
Okay.
that plays a really crucial role in quantum computing.
Got it.
And essentially, entanglement means that you can link two qubits together
Okay.
in such a way that even if they're physically separated,
Huh.
they can influence each other instantaneously.
Okay.
So it's as if they're communicating faster than the speed of light.
That's where my brain starts to melt a little bit.
Yeah, it's a very strange concept to think about.
But the video with Cleo Abram had a good visual for this.
Okay.
They were talking about how, if you drop two pebbles in a pond,
Uh-huh.
they create waves that interact with each other.
Right.
And they form this, unique pattern.
Yeah.
And so in a similar way, quantum computers use this interaction of these entangled qubits to find, the most likely solution to a problem.
Yeah, exactly. It's not about brute force calculation like in classical computing. They're not just trying every single possibility one at a time.
Right.
Instead, they're leveraging this probabilistic nature of quantum mechanics to kind of navigate this vast landscape of possibilities
Yeah.
and then converge on the most likely answer.
Interesting. So, as Cleo Abram put it, these quantum computers are like boats exploring uncharted waters.
I like that analogy.
It's a whole new approach to computation.
Exactly.
Not just a faster version of what we already have.
And that's why there's so much excitement and so much potential surrounding this field.
Yeah, that makes sense.
Yeah.
Speaking of real-world applications, Cleo Abram actually got to see and touch a real quantum computer.
Oh, wow.
And she mentioned a fascinating detail.
Okay.
These machines have to be kept super cold.
Yes.
Colder than outer space.
Yes, they do.
Why is that?
So those extreme temperatures are crucial for protecting the delicate quantum states of the qubits.
Okay.
Because any heat or interference can disrupt those states and cause errors in the computation.
So it's like if you were trying to balance a house of cards in a windstorm.
Any little disturbance could just topple the whole thing over. Exactly. You need to really protect them from any kind of environmental interference.
Okay, so building and maintaining these quantum computers is no easy feat.
No, it's not an easy test.
It's a testament to human ingenuity
Yeah,
and all these researchers around the world.
for sure.
But here's a question that's probably on everyone's mind.
Okay,
Are quantum computers going to break the internet?
that's a good question.
I mean, I've seen headlines about them cracking encryption codes
Right.
and causing chaos.
It's understandable why people are concerned about that.
Yeah.
The Domain of Science video did a good job of explaining Shor's algorithm, which is a theoretical algorithm that if you could implement it on a powerful enough quantum computer, could break the encryption methods
Oh, no.
that we use today to secure, online communication and financial transactions.
So are our bank accounts doomed?
Well, hold on. Let's not panic just yet. While Shor's algorithm is a real concern, quantum computers aren't quite at that stage yet.
Okay.
Um, they would need millions of qubits to actually do that, and the most advanced ones currently have only a few hundred.
Okay. That's a bit of a relief.
Yeah, so we have some time.
But it sounds like a little bit of a race against time.
It is a little bit of a race against time, but here's the fascinating part.
Okay.
While quantum computers pose this threat to current encryption methods, they also offer a potential solution.
Oh, interesting.
So researchers are already developing what they call quantum-safe encryption methods
Okay.
that are resistant to attacks from even the most powerful future quantum computers.
So it's kind of like a cat and mouse game.
It's a constant evolution.
This constant evolution of like code breaking and code protecting.
Exactly. And it's reassuring to know that we have these brilliant minds working on both sides of the equation.
Yes, for sure. I'm glad that people are thinking about this.
Absolutely. And that highlights another important point. Quantum computing isn't just about breaking things.
Right.
It has the potential to unlock incredible breakthroughs in all sorts of fields.
Right. Let's move beyond the fear-mongering
Yeah.
and explore some of those exciting applications.
Let's do it.
We'll do just that in part 2 of our deep dive.
Sounds good. Welcome back to our exploration of quantum computing.
Yes, welcome back.
So in part 1, we kind of laid the foundation.
Yeah, we talked about the basics.
Explored those fundamental differences between classical and quantum computers.
Exactly.
Now let's dive a bit deeper into the different types of quantum computers
Okay.
being developed. And the Domain of Science video did a good job of outlining this.
Okay, so it's not just one type of quantum computer.
Right.
There's like a whole family of them,
It's a diverse field.
each with its own unique approach.
Exactly.
It's like having different schools of thought on how to build these powerful machines.
That's a great way to put it.
Yeah.
One of the most prominent approaches uses superconducting circuits.
Okay, those are the ones that need to be kept super cold, right?
Yes, exactly.
Colder than space.
So superconducting circuits rely on this really fascinating phenomenon.
Okay.
At extremely low temperatures, certain materials can actually lose all electrical resistance.
Wow.
It's like a superhighway for electrons,
Really?
allowing them to flow freely without any loss of energy.
So it's like building a quantum computer inside a super efficient freezer.
Well, not exactly a freezer, but the principle's similar.
Okay.
These circuits are housed in these very sophisticated refrigerators that maintain temperatures just a fraction of a degree above absolute zero.
Wow, so that's incredibly cold. Why go to such extremes?
It's all about protecting those delicate quantum states of the qubits.
Right, right.
Remember, any heat or interference can disrupt those states and then cause errors in the computation.
Yeah, so it's like trying to build a sandcastle on a windy beach.
Yeah.
You need a very stable environment
You need things to be very calm.
to keep everything from falling apart.
Exactly. And one of the advantages of these superconducting quantum computers
Right.
is that they leverage existing fabrication techniques
Oh.
from the semiconductor industry.
Oh, okay. So we can potentially build on the knowledge and infrastructure
Yeah, exactly.
we already have for making computer chips.
Exactly. We don't have to reinvent the wheel completely.
That's good.
So that's why superconducting quantum computers are considered one of the most mature and scalable approaches right now.
That makes sense.
Yeah.
But what about these other types of quantum computers?
Right.
The ones that sound like something straight out of science fiction.
Yeah.
Like the one that uses lasers to levitate atoms.
Ah, yes.
Yeah.
Trapped ion quantum computers.
Oh, cool.
Another very fascinating approach.
Okay.
So instead of using electrical circuits,
Uh-huh.
they use electromagnetic fields to trap individual ions,
Okay.
which are atoms that has an electric charge
Uh-huh.
in a vacuum chamber.
So we're talking about levitating atoms with lasers.
We are.
That's incredible.
It's pretty wild.
But why trap ions?
So by isolating those ions from their environment, we can minimize noise and interference,
Okay.
which is crucial for maintaining the coherence of those qubits.
So it's like creating a perfectly still and silent space
Exactly.
for these qubits to just exist in.
Yeah, just let them do their thing.
Okay.
And each type of quantum computer uses a slightly different method to achieve this.
Okay.
For example, neutral atom quantum computers.
Okay.
They trap atoms in this kind of grid-like structure of light
Okay.
called an optical lattice.
Wait, so we're trapping atoms in a web of light.
Sounds very sci-fi, but that's exactly what they're doing.
This sounds like something out of like a fantasy novel or something.
It does have a certain magical quality to it,
Yeah.
but the science behind it is very solid.
Okay.
And just like trapped ions,
Uh-huh.
these neutral atoms are incredibly well isolated from their surroundings.
Interesting. Okay, so each approach has its own strengths and challenges.
Yeah.
Superconducting quantum computers leverage existing technology.
Right.
They're potentially scalable.
Uh-huh.
Trapped ion computers offer high stability,
Yes.
but maybe they're more difficult to scale up.
A little bit harder. Yeah.
And neutral atoms in optical lattices are a promising new approach
They are.
that combines stability and scalability.
Yeah. It's kind of the best of both worlds potential.
Oh, that's exciting.
Yeah. And there are even more exotic approaches being explored,
Really?
like topological quantum computers.
Oh, yeah, those were mentioned in the Domain of Science video.
Yes.
They sounded very mind-bending,
They are very mind-bending.
like even for this topic.
So topological quantum computers,
Yeah.
they're based on this idea of encoding quantum information in like the global properties of a material.
Okay.
And that makes them inherently resistant to noise and decoherence.
Okay, so instead of relying on like individual particles, we're talking about harnessing the properties of the material itself.
The material itself, exactly.
Oh.
It's like the difference between writing a message on a piece of paper, where it can be easily erased or smudged,
Okay,
and carving that message into a stone tablet,
got it.
where it's much more durable.
That's a great analogy.
So these topological quantum computers are, in theory, much more robust.
Okay, but it sounds like finding the right materials
Yeah,
and manipulating them at that quantum level.
it's not easy.
That's no easy task.
You're absolutely right. It's a very challenging field.
Yeah.
Topological quantum computing is still very much in its early stages,
Mm.
but it holds immense promise
Okay.
for building these fault-tolerant and scalable quantum computers.
That's exciting.
It is exciting.
To think that we have so many brilliant minds
Yeah, it's like a huge global effort.
exploring different avenues,
Exactly.
pushing the boundaries of what's possible.
Pushing the limits of physics and engineering.
It's like a grand scientific adventure,
Yeah.
with each team charting its course through uncharted territory.
And just like any grand adventure, there will be challenges and setbacks along the way.
Right, of course.
But the potential rewards are so significant that it's a journey worth taking.
Okay, speaking of rewards, let's shift gears a little bit
Okay.
and explore some of the amazing applications of quantum computing in part 3 of our deep dive. All right, so we've covered, the basics of quantum computing
Laid the groundwork.
and looked at all these different types of these crazy machines
Yeah.
that are being developed.
A lot of different approaches out there.
But now let's talk about the so what
The
factor.
big question.
Why are all these brilliant minds and resources being poured into this field? What are the payoffs?
Yeah, what are the potential applications that make all this effort worthwhile?
Exactly.
It's a great question. And the answer is that the potential applications of quantum computing are vast and truly transformative.
Okay.
I mean, they have the potential to revolutionize fields ranging from medicine and material science
Okay.
to artificial intelligence and even our understanding of the universe itself.
Wow, that's a pretty broad scope. Let's start with something that captures the imagination.
Oh.
What's the application that really gets people fired up
Yeah.
about the possibilities of quantum computing?
I think one of the most captivating applications is quantum simulation.
Okay.
As we touched upon earlier, quantum computers have this unique ability to simulate quantum systems,
Uh-huh.
the very building blocks of nature.
Okay, so instead of just crunching numbers,
Right.
we're talking about simulating the behavior of molecules,
Yes.
atoms,
Uh-huh.
maybe even the fundamental forces of the universe.
Exactly. Imagine being able to design new materials with properties that we can only dream of today,
Right.
or create life-saving drugs that are tailored to an individual's genetic makeup.
Wow.
We could even gain a deeper understanding of these mysteries of dark matter and dark energy.
Wow.
I mean, the possibilities are truly mind-boggling.
It's like opening up a whole new chapter in the book of scientific discovery.
Yeah, it really is.
But let's shift gears a little bit.
Okay.
What about some more practical, everyday applications?
Sure.
Something that could impact our lives in the near future.
Yeah, well, one area where quantum computers could make a significant impact is in optimization.
Okay.
So many real-world problems,
Yeah.
from logistics and finance to traffic flow and urban planning.
Okay.
They involve finding the best solution among a vast number of possibilities.
Okay, so things like finding the most efficient route for a delivery truck
Yes.
or optimizing a city's traffic flow to reduce congestion.
Precisely. And these types of problems can quickly become too complex for classical computers to handle efficiently.
Yeah, it's a lot of variables.
But quantum computers, with their ability to explore multiple possibilities simultaneously, could find optimal solutions much faster.
Interesting. So it's like having a superpowered brain
Yeah.
that can just sift through mountains of data
Yeah,
and find the needle in the haystack.
exactly. And that could have a huge impact on everything from business operations to our daily commutes.
Yeah, that would be great to get rid of traffic.
That'd be nice.
Yeah. Okay.
And the potential applications extend even further.
Okay.
Quantum computers could also revolutionize machine learning and artificial intelligence,
Oh, wow.
potentially leading to the development of entirely new types of algorithms that are far more powerful and efficient.
AI is already transforming so many parts of our lives.
It is.
How could quantum computing take it to that next level?
Well, imagine AI systems that can diagnose diseases much earlier and with greater accuracy,
Okay.
or develop personalized learning plans that cater to each student's unique needs.
Wow.
Quantum computers could even enhance our creative endeavors,
Really?
leading to AI that can compose music, write poetry, or create art that rivals human creativity.
It's both exciting and a little bit daunting to think about,
Yeah.
like what all this means.
Yeah.
We're talking about a really fundamental shift in how we solve problems and how we interact with the world around us.
It's a powerful technology with the potential for both great good and potentially harm. So it's crucial that we approach its development and deployment responsibly,
Of course.
considering both its benefits and its risks.
Yeah.
We need to ensure equitable access to its benefits and safeguard against its potential misuse.
Absolutely. It's a reminder that technology is a tool,
It is.
and it's up to us to use it wisely and ethically.
Yeah, well said.
Quantum computing is not just a scientific or a technological endeavor.
Right.
It's a societal one.
It really is.
That's a great point.
Okay.
And so as we wrap up this deep dive into quantum computing,
Yeah.
hopefully we've left you with a sense of wonder.
Yeah. A little bit of excitement.
And desire to learn more.
This field is evolving so rapidly.
Yes, for sure. It's incredible.
So there's always something new to discover.
We've gone from, those basics of bits and qubits to exploring the different types of quantum computers.
All these crazy machines.
And these mind-blowing applications.
Yeah.
It's been a wild ride.
It has.
But this field is still very much in its early stages.
It is.
There are tons of challenges to overcome.
There are.
But the rewards could be so vast.
Yeah, the potential is truly limitless.
That the journey is definitely worth taking.
It is. And for all of our listeners out there, we encourage you to continue exploring this fascinating field.
Yes. Go read more. Watch videos, ask questions, and let your imaginations run wild with the possibilities.
Yeah, who knows? You might just be the one to make the next groundbreaking discovery in the quantum realm.
Exactly. All right. Until next time.
Until next time.
Keep those quantum questions coming.